In this video, I'm going to discuss case number 2 about trigonometric substitution. Okay. Case 2 is when the integrand contains an expression of the form square root of a squared plus u squared. And it must be that a should be greater than 0. So again, we're going to introduce a new variable theta. So the substitution is, for case number 2, the substitution is u equal to a tangent theta. Okay, let's try this one. Evaluate the integral of dx over square root of x squared plus 9. And it's equal to integral of dx over square root of x squared plus 3 squared. To conform with this form, a squared plus u squared. You can interchange this one since positive lang ang sign. Or you can interchange this to 3 squared plus x squared to conform with this. So our substitution is let x equal to 3 tangent theta. X being our u and 3 our a. So u equal to a tangent theta. So differentiate dx is equal to 3 secant squared theta d theta. And then get the expression of tangent theta. It's x over 3. And then for beginners, you may need this one, triangle, being your guide. And if this is your theta, then tangent is opposite over adjacent, so it's x over 3. So the hypotenuse is square root of x squared plus 3 squared or x squared plus 9. Since we have secant theta, then we'll get the expression of secant theta. Remember that secant theta is the reciprocal of sine, a cosine. And cosine is adjacent over hypotenuse. Therefore, secant theta is hypotenuse over adjacent. Hypotenuse over adjacent. And to cross multiply, square root of x squared plus 9 is equal to 3 secant theta. So let's substitute dx replaced by this one, 3 secant squared theta d theta. And square root of x squared plus 9 replaced by 3 secant theta. And let's cancel out 3 secant squared theta over 3 secant theta. What remains is secant theta sa numerator. Okay, and this is a standard form. The integral of this is ln of secant plus tangent. Okay, so you can replace secant theta by this and tangent theta by x over 3. Okay, so for this one, this is already correct. But if the answer has a standard format, then we can simplify this further. Okay, but again, this is already correct, no? Then na step correct. Pero if you want to arrive at a specific form, then you're going to need this one, need the simplification. Okay. These two terms can be combined. No? The numerators can be combined, and the denominator, we can extract it. And from here, we can apply the law in logarithms that when you have ln of xy, you can separate x and y. You know? Ln of xy is just equal to ln of x plus ln of y. So for the first term, we can break this one into two terms. ln of 1/3 plus ln of this. Okay, product man eh. 1/3 being our x and this one being our y. We have this. And since And since ln 1/3 is a constant, we can combine this one with c being a constant now. Constant plus another constant will still be equal to a constant. So this one and then this one combine, and you can just replace it by c again being a constant. So the final answer for this is this. ln of square root of x squared plus 9 plus x plus c. Pero pag if this is not given, this is the final answer, this is the final form, then this one is correct. Then na part, okay, correct na. Another one. Evaluate the integral of dx over x times x squared plus 4. So 4 is 2 squared. So let x equal to 2 tangent theta dx 2 secant squared d theta, and then same procedure. Express tangent theta x over 2, and then you draw a triangle as your guide. Tangent is opposite of adjacent to x over 2, and then hypotenuse square root of x squared plus 4, and then get the expression of secant hypotenuse over adjacent, and then you cross multiply. Uh, you have the square root of x squared plus 4 equal to 2 secant theta. So we are ready to substitute. Dx is 2 secant squared theta d theta. And then for the denominator, we have x, you have 2 tangent theta, and then square root of x squared plus 4 is simply 2 secant theta. And then let's cancel out 2 secant squared theta over 2 secant theta. What remains is secant theta. And so we have 1/2 secant sa numerator, tangent sa denominator. And then we have this identity. Secant theta is 1 over cosine, reciprocal identity. While ang tangent is sine over cosine. So if you want to divide secant by tangent, secant over tangent, cosine theta will be cancelled out. So what remains is 1 over sine theta. Okay, so 1/2 d theta over sine theta. But we don't have an integral of 1 over sine theta. So let's replace this one by the reciprocal of sine. 1 over sine theta is simply cosecant theta. And this is a standard form, integral of cosecant theta. The integral is ln of cosecant minus cotangent. 1/2 ln of cosecant theta minus cotangent theta, plus c. So first, we'll get the expression of cosecant theta. Cosecant is the reciprocal of sine. And sine is opposite over hypotenuse. Therefore, cosecant is hypotenuse over opposite. Hypotenuse over opposite x. While cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. Therefore, cotangent is adjacent over opposite. So it's 2 over x. So, okay. Secant minus cotangent. This one minus this. You can combine. They have the same denominator. So this is their final answer. Okay, so that's all for case number 2. So every time you will encounter the form u square plus a square plus, yeah, then your substitution is u equal to a tangent theta. Thank you for watching.